Two new Earth-like planets discovered near Teegarden star. An international research team led by the University of Göttingen has discovered two new Earth-like planets near one of our closest neighboring stars. Teegarden star is only about 12.5 light-years away from Earth and is one of the smallest known stars. It is only about 2,700 degrees Celsius warm and about 10 times lighter than the Sun. Although it is so close to us, the star wasn't discovered until 2003. The scientists observed the star for about 3 years. The results were published in the journal Astronomy and Astrophysics. Their data clearly show the existence of two planets. The two planets resemble the inner planets of our solar system, explains lead author Matthias Seckmeister of the Institute for Astrophysics at the University of Göttingen. They are only slightly heavier than Earth and are located in the so-called habitable zone, where water can be present in liquid form. The astronomers suspect that the two planets could be part of a larger system. Many stars are apparently surrounded by systems with several planets, explains co-author Professor Stefan Dreisler of the University of Göttingen. Teegarden star is the smallest star where researchers have so far been able to measure the weight of a planet directly. This is a great success for the Carmenes project, which was specifically designed to search for planets around the lightest stars, says Professor Ansgar Reiners of the University of Göttingen, one of the scientific directors of the project. Although planetary systems around similar stars are known, they have always been detected using the transit method. The planets have to pass visibly in front of the star and darken it for a moment, which only happens in a very small fraction of all planetary systems. Such transits have not yet been found for the new planets. But the system is located at a special place in the sky. From Teegarden star you can see the planets of the solar system passing in front of the Sun. An inhabitant of the new planets would therefore have the opportunity to view the Earth using the transit method, says Reiners. The new planets are the 10th and 11th discovered by the team. Carmenes is carried out by the Universities of Göttingen, Hamburg, Heidelberg, and Madrid, the Max Planck Institute für Astronomie Heidelberg, Instituts Consejo Superior de Investigaciones Científicas in Barcelona, Granada, and Madrid, Thüringer Landesternwarte, Instituto de Astrofísica de Canarias, and Calar Alto Observatory. Earth's heavy metals result of supernova explosion. Research reveals that gold on your ring finger is stellar, and not just in a complementary way. In a finding that may overthrow our understanding of where Earth's heavy elements such as gold and platinum come from, new research by a University of Guelph physicist suggests that most of them were spewed from a largely overlooked kind of star explosion far away in space and time from our planet. Some 80% of the heavy elements in the universe likely formed in collapsars, a rare but heavy element-rich form of supernova explosion from the gravitational collapse of old, massive stars typically 30 times as weighty as our Sun, said physics professor Daniel Siegel. That finding overturns the widely held belief that these elements mostly come from collisions between neutron stars or between a neutron star and a black hole, said Siegel. His paper co-authored with Columbia University colleagues appears today in the journal Nature. Using supercomputers, the trio simulated the dynamics of collapsars, or old stars whose gravity causes them to implode and form black holes. Under their model, massive, rapidly spinning collapsars eject heavy elements whose amounts and distribution are astonishingly similar to what we observe in our solar system, said Siegel. He joined U of G this month and is also appointed to the Perimeter Institute for Theoretical Physics, in Waterloo, ONT. Most of the elements found in nature were created in nuclear reactions in stars and ultimately expelled in huge stellar explosions. Heavy elements found on Earth and elsewhere in the universe from long ago explosions range from gold and platinum, to uranium and plutonium used in nuclear reactors, to more exotic chemical elements such as neodymium found in consumer items such as electronics. Until now, scientists thought that these elements were cooked up mostly in stellar smash-ups involving neutron stars or black holes, as in a collision of two neutron stars observed by Earth-bound detectors that made headlines in 2017. Ironically, said Siegel, his team began working to understand the physics of that merger before their simulations pointed toward collapsars as a heavy element birth chamber. Our research on neutron star mergers has led us to believe that the birth of black holes in a very different type of stellar explosion might produce even more gold than neutron star mergers. What collapsars lack in frequency, they make up for in generation of heavy elements, said Siegel. Collapsars also produce intense flashes of gamma rays. 80% of these heavy elements we see should come from collapsars. Collapsars are fairly rare in occurrences of supernovae, even more rare than neutron star mergers, but the amount of material that they eject into space is much higher than that from neutron star mergers. The team now hopes to see its theoretical model validated by observations. Siegel said infrared instruments such as those on the James Webb Space Telescope, set for launch in 2021, should be able to detect telltale radiation pointing to heavy elements from a collapsar in a far distant galaxy. That would be a clear signature, he said, adding that astronomers might also detect evidence of collapsars by looking at amounts and distribution of heavy element S in other stars across our Milky Way galaxy. Siegel said this research may yield clues about how our galaxy began. Trying to nail down where heavy elements come from may help us understand how the galaxy was chemically assembled and how the galaxy formed. This may actually help solve some big questions in cosmology, as heavy elements are a nice tracer. This year marks the 150th anniversary of Dmitry Mendeleev's creation of the periodic table of the chemical elements. Since then, scientists have added many more elements to the periodic table, a staple of science textbooks and classrooms worldwide. Referring to the Russian chemist, Siegel said, "We know many more elements that he didn't." What's fascinating and surprising is that, after 150 years of studying the fundamental building blocks of nature, we still don't quite understand how the universe creates a big fraction of the elements in the periodic table.